Hey guys, Easy Science here, studying for an exam or just learning for fun. You've come to the right place. Hey guys, I know it's been a while, but I'm coming back to making videos, and let's get started, guys. So today's topic is going to be radiation and the different types of it. So as we can see, there are 4 types of radiation: electromagnetic radiation, particle radiation, gravitational waves, or they get transported as gravitational radiation, and acoustic radiation. So in general, radiation is a transmission of energy through space or through a certain medium. As we will see, some of these vary differently, but always they carry energy. Here we have electromagnetic radiation, where these are waves that travel through space-time in the electromagnetic field, which is a field that is created by electric charges. As we can see here, there are many types of radiation in the electromagnetic spectrum. This is called the electromagnetic spectrum. So we start off with gamma rays as being the smallest, and it goes up in frequency to long radio waves. This kind of resembles, as you might know, hertz for sound frequency. As sound is also a type of wave, you wouldn't know that radiation, as we think of it, as like gamma rays, also can be measured in frequency. Visible light is what we see and can only see and detect, gives off light to our brain. UV rays, where we get sunburns from, are just a bit smaller. X-rays can be used to detect bone and used in practical purposes. Gamma rays are dangerous, as the smaller you go, the more dangerous they become, as they are considered ionizing radiation, where they can ionize atoms and give off certain health effects which are bad. Infrared rays can give off heat, and as you go up, the waves become up, and with radio waves we can have everyday use for them, as they can travel long distances and be detected easily by antennas. So electromagnetic waves have many purposes in life. The second type of radiation we have is particle radiation. You might have heard of this too. There are lots of types of particle radiation, but the most known are alpha radiation, beta radiation. These are all Greek letters, and gamma radiation. Neutron radiation too. Most of these are released by radioactive decay, where, as we know, there are isotopes which sometimes are unstable, meaning they will lose energy through radioactive decay, where one of these particles are released as particle radiation, which essentially carries energy in a wave-like form. First one, alpha decay, where an unstable isotope releases an alpha particle, as seen right over here. This alpha particle, as you can see, consists of 2 protons and 2 neutrons. This indeed is helium-4, meaning that after alpha decay happens, that isotope will lose 2 numbers in its atomic number, and its atomic weight will be lowered by 4. Mass number. This hence lowers its energy levels by a lot. The beta decay releases a high energy electron electron. This is a very high energy particle. Also, as seen here, there are different types of beta decay. where a neutron can also change itself to undergo and create a proton emission, electron emission, or neutrinos. There's also beta plus and beta minus decay. Gamma emission is when from a daughter cell or from another cell, daughter molecule, nucleus, which is after fission, it can release gamma radiation to lower it to an even lower state of energy. Gamma radiation usually happens after alpha and beta radiation have happened. Gamma radiation in itself is in the electromagnetic spectrum and is the highest energy state of a photon. Neutron emission in radiation is very unstable, as these neutrons are released and go to form other isotopes with other nucleuses, which can further release more neutrons. The average lifespan is about 880 seconds. Neutron emission are very unstable and hence ionizing, as they can form ionic substances, as they can turn into a proton, electron, or antineutrino. A good information is to know that alpha radiation can be stopped by a piece of paper. Beta radiation can be stopped by an aluminum sheet, which is thicker and more dense. Gamma radiation can pass through all of these, but can be stopped by concrete, lead, as we all know, or steel, which are very dense. The next one we're going to look at is acoustic radiation. In acoustic radiation, there are 4 types of main things. There's vibration, sound, ultrasound, and infrasound. Vibration is basically a wave that is formed through a medium. Sound, as we know and are able to detect through our ears, is a vibration through the air with changing air pressures. These are very important for us as we can use it to communicate and hear things. Sound, as we talked about with electromagnetic radiation, can be measured in hertz. There are 2 other types of radiation, infrasound and ultrasound. Ultrasound we are not able to detect it, as it is higher than 20,000 hertz. It could go even up to few gigahertz. Infrasound is below 20 hertz. It is very low, and we are not able to detect it either. Usually, as we know, bass sound is from 20 to 200 hertz, which is very low. Ultrasound can be used in therapy to detect things such as baby pictures and other things. Infrasound is also a bit weird, as you can get headaches from infrasound, as it can distort things in your brain. There are also weapons used with infrasound, which can be launched at you and you will not be able to detect it, but it can be very high, such as gigahertz. The volume will be very high. This can damage your ears badly. Gravitational radiation is very similar to electromagnetic radiation, but it is formed on the same basis, as there is a field, but this time it's a space-time field. When there's a disturbance with an accelerated mass, there are waves created. Like when you drop a rock in the water, there are waves that oscillate from the source in the equilibrium point. Same thing here, such as if 2 black holes merge. There's a video which you can check out, I'll link in the description. When they combine, it's like when you drop two things into water and then they just oscillate from that. That's what happened. The accelerated masses of the black holes created waves that came from that. They can be detected and they move at the speed of light and similarly forms as electromagnetic radiation. So as you might have learned today, there are four types of radiation: electromagnetic radiation, particle radiation, gravitational wave, and acoustic radiation. Thank you for watching this video. Okay guys, like I said, thank you for watching this video. I'm sorry I haven't posted in a while. I was kind of having a job during the summer, so that kind of held me up in sometimes, but now I'm going to be posting much more, and to the starting school year, just help you guys out with some science tips, maybe help you in classes. Guys, like the video, subscribe. Easy Science out.